Trigonometric Identities. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. Before working on trigonometric identities, we must review what are the basic trigonometric ratios. A triangle in which one angle is a right angle 90 degrees is called a right triangle. Recall that the side opposite the right angle is called the hypotenuse, and the remaining two sides are called the legs of the triangle. Consider a right triangle with theta as one of its acute angles. Using the three sides of this triangle, we can form exactly 6 ratios. The ratios of the sides of a right triangle are called trigonometric ratios. 3 common trigonometric ratios are the sine, cosine, and tangent. Sine is defined as the ratio of the opposite to the hypotenuse. Cosine is defined as the ratio of the adjacent to the hypotenuse. And tangent is defined as the ratio of the opposite to the adjacent. In these definitions, the terms opposite, adjacent, and hypotenuse refer to the length of the sides. Notice that adjacent means next to the angle, and opposite means opposite the angle. The first 3 ratios established above are referred to as the basic trigonometric ratios. If we flip these 3 ratios over, we have 3 more ratios. These 3 new ratios are reciprocals of the ratios of the basic trigonometric ratios. Cosecant is a multiplicative inverse of sine. Secant is a multiplicative inverse of cosine. Cotangent is the multiplicative inverse of the tangent. Let's start by showing what an identity is and what identity is for. An identity is an equality relationship between 2 mathematical expressions. For example, in basic algebra, students are expected to master various algebraic factoring identities such as these. Identities such as these are used to simplify algebraic expressions and to solve algebraic equations. In trigonometry, it is the same. We will learn trigonometric identities to simplify trigonometric expressions and to solve trigonometric equations. Before continuing, it's important that you understand the difference between an identity and an equation. Look at the first expression. It's an identity because for any values of x and y, it's always true. Look at this other expression. It's an equation because it's true for certain values of x and y. An expression is an identity if it's true for all values of variables. And an expression is an equation if it's true for some values of the variables which need to be found. Identities are equations true for all replacements of the variable for which they are defined. In short, you can think of an identity as an equation that is always true. You may have observed some relationships that exist among the 6 trigonometric ratios of acute angles. For example, the tangent of theta equals to b divided by a. If we divide the numerator and the denominator by the hypotenuse c, we can replace the numerator with sine of theta and the denominator by the cosine of theta. And we get the first quotient identity. The cotangent of theta equals to a divided by b. If we divide the numerator and denominator by the hypotenuse c, we can replace the numerator with the cosine of theta and the denominator by the sine of theta. And we get the second quotient identity. Now we take the cosecant of theta. If we divide the numerator and denominator by the hypotenuse, we can simplify the numerator and replace the denominator with the sine of theta. Thus, we obtain the first reciprocal identity. Observe the secant and the cotangent. If we do the same, we get the other identities. These three identities are known as reciprocal identities. We will now derive one of the most important trigonometric identity. Refer to the right triangle above. We write the Pythagorean theorem. The Pythagorean theorem says that in a right triangle, the square of the leg A plus the square of the leg B is equal to the square of the hypotenuse C. Dividing each side by c squared, we get the following expression. We replace b divided by c with sine of theta and a divided by c with cosine of theta. This is the Pythagorean formula for sines and cosines. This is probably the most important trigonometric identity. It's customary to write sine square of theta instead of sine of theta square. Likewise for cosine and the other trigonometric functions. We will use the same notation for other powers besides 2. From this first identity, 2 additional identities can be created. Pay attention. We start with this first Pythagorean identity, dividing both sides by cosine square of theta and then substituting and simplifying, we get the new identity. Similarly, by dividing both sides by sine square of theta, we obtain a new identity. The first set of identities are known as quotient identities or ratio identities. As we can see, the tangent of an angle is the ratio of the sine to the cosine, and cotangent of an angle is the ratio of the cosine to the sine. The second set of identities are known as reciprocal identities, since the reciprocal functions secant, cosecant, and cotangent are the reciprocals of the cosine, sine, and tangent. The third set of identities are known as Pythagorean identities, since these identities are an immediate consequence of the Pythagorean theorem. The identities we have already seen play a central role in trigonometry because we can use them to relate any trigonometric function to any other. In other words, we only need to know the value of one of the functions to find the others. Let's see how it works. We know 120 degrees equals 180 minus 60 degrees. So 120 degrees lies in the second quadrant and the reference angle is 60 degrees. Let's start by finding the sine of 120 degrees. In the second quadrant, the sine value is positive. The sine of 120 degrees is the square root of 3 divided by 2. In the second quadrant, the cosine value is negative, so the cosine of 120 degrees is minus 1/2. From now, we can use the identities to find the value for the other trigonometric functions. Tangent is sine divided by cosine. Substitute the values of sine and cosine of 120 degrees and simplify. We will do the same to find cosecant, secant, and cotangent of 120 degrees. Look at the next example. We can see one more time how we can find all trigonometric functions from the value of 1. If cosine of theta equals 3 divided by 5 and theta is in quadrant 4, find the values of all the trigonometric functions at theta. We write the first Pythagorean identity and replace the cosine of theta with 3 divided by 5 to find the sine of theta. Since the angle is in quadrant 4, the sine of theta is negative. The remaining functions can be calculated using identities relating them to sine and cosine. Pay attention. The identities enable us to simplify complicated expressions. We do this by using trigonometric identities. The next examples illustrate this. Simplify the following expressions. As a general rule, the first step in simplifying a trigonometric expression is to change everything into sine or cosine. We use the quotient identity for the tangent. We now bring the fractions to the common denominator. And we rewrite the expression over a common denominator. We use the first Pythagorean identity. And we use the reciprocal identity for the secant. To simplify this expression, we use the quotient identity for the cotangent and the reciprocal identity for the cosecant, and simplify. For the item C, we first use the Pythagorean identity for the cosecant square. Then we use the quotient identity for the cotangent and the reciprocal identity for the cosecant. Finally, we use the most important Pythagorean identity.